All right, geometry, here we go. Let's do a couple problems off the 10-6 worksheet. This was a really long section of notes with a ton of vocabulary in it. We're going to work out 4 problems right here and see how we do. Okay, so for this first set of problems here, they say if an angle is given, you're supposed to name the arc that it makes, and if an arc is given, you're supposed to name the central angle. So if we look at number 1, they gave us the name of an arc right here, arc BC, so we're looking at the second half of the directions here. If an arc is given, we're supposed to name the central angle that goes along with that arc. So when we talk about a 2-letter arc, this one is just arc BC, we have to be talking about a minor arc. If we were doing a major arc or a semicircle, we would need 3 letters to do that. So arc BC very simply starts at point B and ends at point C. So we're talking about this relatively small arc here, and they want to know the name of the central angle that creates it. So all we do is we take a look at the radii that go to point B and C. Here's one of them, QB, and the other one right here is QC. So the central angle that creates that minor arc is this angle right here. Remember, everybody, that a central angle, as the name kind of implies, is an angle whose vertex is at the center of your circle. So if we wanted to name this thing, Q is our vertex, that has to be the middle letter, so we'd start at one of the endpoints, probably B, go from B to our vertex, which is Q, and then go to the other endpoint. So this could be arc BQC, or remember, guys, when we're naming an angle, you could just as well go the opposite direction and make it arc CQB. Either one of those would be fine. But the important thing there is that Q has to be the letter in the middle because that's the vertex of the angle. You could not name this as, say, BCQ. That one wouldn't work out. If you take a look at number 2, let me go ahead and do this one with you here too. In this case, now it's the first set of directions. An angle is given to us, and we're supposed to name the arc that it makes. So angle HQG is going to start at H, go to Q, and then back out to G right here. So we're talking about this central angle. They want to know what arc that angle creates. So now we're talking about this arc right here. It's a minor arc because it makes up less than half the circle, and with a minor arc you could name it just with 2 letters. So if we were going clockwise here, we would start at H and end at point G and put the arc symbol over the top, arc HG, or again, you could just as well name that backwards and call it arc GH. You really can go in either order you want there. Okay, 3 and 4 are pretty similar. Let's talk about number 5 here, where it asks you to find the measure of the arc or the central angle indicated. And then this last little statement right here tells you, and this is an important assumption when you're looking at figures like this, that things that appear to be a straight line or a diameter actually are. Okay, so they want to know the measure of arc IK. Arc IK, it's 2 letters, so it's a minor arc. It's less than half the circle. It starts here at I, and it ends at point K right over here. So we're talking about this arc right over here. Well, there's a bunch of different ways to go about doing this, but the important idea that I want to make sure that we get here is the relationship here between the measure of a central angle and the measure of the arc that it creates. For example, you've got a 60-degree central angle right here. That means that arc GH is going to have to be exactly 60 degrees as well. If I look down a little bit further, now I know that arc HI is 54 degrees. That means that this angle here is 54 degrees as well. So let's see what else it is that we're looking at here. We're looking here for arc IK, which I've kind of highlighted here in purple, and that's made up of 2 smaller arcs. So let's see what we know. We've got a 60-degree central angle right here, and if I go back to the concept of vertical angles, which we learned, one of the first things we learned this year back in chapter 2, I know that this vertical angle right here has to be 60 degrees as well. Those 2 angles have to be congruent. And if that central angle is 60 degrees, then we know that arc KJ has to have a measure of 60 degrees as well. So that's part of the information that we needed. But the other thing here that's a little bit trickier, we need to know the measure of arc IJ right here, which I'm doing in blue. And that we could find if we knew the measure of this central angle right here. So what I want to do is take advantage of the fact that if I put these 3 angles here together, we can assume from the diagram that GJ is a diameter. And that means that these 3 angles here, 1, 2, and 3, have to add up to 180 degrees. So if I said something like 60 plus 54 plus x, that maybe being our unknown angle right there, if that sum was 180, let's see what we've got right here. Putting those two together, I'd get a 114 plus x is equal to 180, and then subtract that 114 from both sides, and we'd get x is equal to 66. So that 66, I got a lot of mess going on right here. So that 66 is the measure of this angle right here, and it's also the measure of this arc right here. So again, now we're looking for the measure of arc IK, which is these two minor arcs put together. So the measure of arc IK is going to equal the sum of 60 plus 66, and that's how we're going to get 126 degrees for the measure of that arc. That's actually using an idea called the arc addition postulate. I don't know that it's been formally introduced yet, but basically you can add up these two little arcs and get the measure of the big one. Not too bad, I don't think. Okay, so try 6 through 8 there on your own. Let's jump to number 9. So now in this problem, they're asking you to find the circumference of each circle here. So we learned two different variations for the formula for circumference, although they're really the same thing. The main one, the primary formula we tend to use for circumference, is 2 times pi times the radius of a circle. However, 2 times your radius is always going to get you the measure of a circle's diameter. So you could replace the 2r with a d for diameter, and both of these formulas work just fine. It's really just a question of what information is presented to you. Well, in this problem, they gave us this little 8-mile piece right here, and that segment that I'm coloring in blue right now is a radius of that circle. So we're going to go ahead and use this version. So again, trying to follow my format right here. Step 1, write the formula. Step 2, fill in what you know. Circumference is 2 times pi times a radius of 8. And that's really it. Step 3 then, the 2 times pi times 8. The directions didn't say, although you can tell from the answer here, and this is going to be my general default direction for you guys. Unless it tells you to round, let's try to make our answer exact. So what I would do here is just multiply the 2 times the 8 to get 16, and the pi, kind of like a variable or a square root of 3, just tags along for the ride. The radius was given to us in miles, and nothing changes within the formula here. Circumference is a distance, so that's going to remain miles for your answer there. All right, so that was number 9. If I'm not mistaken, I think 11 and 12, they give you the length of a piece coming all the way across. That's the diameter, so in those cases, you would use this formula right here, or that version of it. Okay, and the last tricky thing right here in 10.6 that I put on the worksheet is the concept of the length of an arc. So if you can see this arc right here is highlighted, they want us to come up with the length of this. So there's a formula for arc length. As we said in our video on the notes, we always tend to use the variable s for arc length. And really the way I like to think about it is that the arc length is part of a circle's circumference. So I'm going to put the formula for circumference right here, which is 2 pi r. But we don't want all of the circumference. We only want a part of it. So that's why we're going to multiply that formula by a fraction. And that fraction is going to have 360 on the bottom because every circle is made up of a total of 360 degrees. And then we like to put theta, that Greek letter again, to represent the measure of our central angle or the measure of our arc. Those are both really the same thing. That was bad. All right, so let's do that. I just wanted to move this over a little. Okay, so that's step 1. Write out the formula. Step 2, let's fill in what we know. Arc length is equal to, well, I want to know the degree measure of this arc right here. That's the same as the degree measure of the central angle inside of it. So that's going to be a 60 over 360 multiplied by 2 times pi times a radius, which they gave us right here, of 5 feet. And that takes care of all of the previously unknown quantities on the right-hand side. So now we're ready to go to step 3 and put all that into our calculator at once. Now, this is a spot where the Texas Instruments calculators work a lot better than the one you might be using on your phone, because that's probably just going to give you a decimal here. So if I type in 60 over 360 as a fraction, get out of there, and then do times a 2 and times of 5. I'm going to leave the pi out of there completely. My calculator gives me a fractional answer of 5 over 3. So I'm going to go ahead and write that 5 over 3, and the pi, which I didn't type in, just tags along for the ride here. So I've got 5/3 pi. Everything here was measured in feet. You'll notice in their answer right here, they've included the pi in the numerator and made it 5 pi over 3. Those are identical answers, everybody. When you've got a factor there, you can either include it in the numerator, or you can leave it after the fraction as a whole, but you can't put it in the denominator. 5 over 3 pi, looking like this, would not be the same answer right there, so that is one we're not going to do. Okay, so try 14 through 16 on your own, check all your answers, and let me know if you guys have any questions. Good luck.